So we have started like this concept like work done by the net work done by the then string is zero. Simply work done by the string is zero. So this is clear to you. Again, I will
Yes,
explain.
yes.
Okay, okay. Now after this, write down properties of. I think write down first properties of one properties of tension. Properties properties of tension. Tension force. Under this, write down first point tension. Hmm. Write on the first point. Tension is present. Tension is present at each and every point of the string. At each and every point of the string. Every point of string. To stop. Next is value of tension. Value of tension is same if a string is massless. If a string is massless. Okay. If a mass of a string is not given, important note. If a mass of a string is not given, then it is considered massless. Okay. Next point. Third point. Tension on both sides of the pulley tension on both sides of pulley. I will tell what is pulley. Let's write these points first. Is same if pulley is massless or smooth. pulleys, massless, or smooth. Clear? Now, what is pulley? Write down what is pulley. What is pulley? It is a circular body, free to rotate, free to rotate. We'll stop. If shape is not given, if shape is not given, then pulley is a disc. Then take pulley, shape is disc. Okay. Clear?
Yes, sir.
Did you write?
Yes, sir. I know.
Okay. Now look at here. This is the 1 minute. This is a case. This is the pulley is just like a circular disc, like circular shape. Circular body free to rotate. This is pulley. Clear? This pulley has center like this. Did you see like pulley on a well? One circular arrangement is there on a well. Clear? One circular arrangements are there, and on that like wheel, we said actually wheel. Pulley is just like a wheel. Okay, it is free to rotate. It is mainly used on a in industry, and we are using that in a on a well. We are taking a bucket of water from the well with the help of pulley. So pulley help us to in that process. So I just do one thing like, see what I'm doing. I will take a one wire or a string like this. It is straight, okay, and these are the free ends. Again, I will draw. Okay, some error is there. What I'm saying, just see. This is the pulley, clear? And on this pulley, I will attach one wire like this or a string like this. One string, same string, okay? One is one string, single string. Okay. Now, this is ceiling. Ceiling means like, ceiling.
Yes.
So this is ceiling. I will attach. What I will do? I will take one more string like this. Okay. Now these are the free ends. Did you see these are the free ends? These are the free ends. In it, I'm showing you free, but actually after when I attach, it is not free. Clear? These are free ends of the string. Now what I will do? These are free ends. Okay, I'm writing here free ends. Ends are free. Ends of the string is free. Free ends. Now what I will do? I will simply, now what I'm doing, just look at carefully. This is the pulley. The same string is going to attach two blocks. like this. Okay. Now attach two blocks. This block is having mass, for example, 1 kg. This is 4 kg. Okay. And at the top, you just fix this pulley with this support. Fixed support. Okay. This is also this entire arrangement is known as fixed support pulley because this is fixed support, fixed support. Okay. This entire arrangement is known as fixed support pulley arrangement. Clear? Now, once you attach these two blocks with a string, now you have you seen like how many strings are here? Two strings.
One.
One string is connecting these two blocks like this. Okay. The same string is connecting 1 kg and 4 kg block. You can check. Okay. This is one string. It is not two string. Clear? One string. There is one more string that is which is connecting this pulley with a fixed support. Can you check?
Yes, sir.
Okay. So now I'm saying what? All these pulleys, if nothing is given, always take the mass. These are inextensible massless string. Strings are both the strings. Okay, I'm talking about both the string. These are inextensible. In 99% of the question, it will be there. But in some question, pulley has also mass. Inextensible massless string. Clear? Okay. So tension is present at each and every point of the string. If you ask me, sir, what is the tension at this point? Every point. Once you attach a block 1 kg, 4 kg mass to this string, then it become tight. Here it is loose. If you ask me, here a string is loose. Once you fix it with a support, and once you attach 1 kg and 4 kg mass or block to this string, then the string become tight. Clear? And once the string become tight, then there is some tension will occur. There is some tension force will generate in the string. Now, what is the direction of tension force? For example, if I take 1 kg block is my system, this is my system. If I draw the free body diagram, this is my system. Okay. Now, look at carefully on this. Gravity is applying a force like this, m into g. In which direction tension will occur on this block?
Opposite to gravity.
Very good. Like this. Remember, this T is due to a string on the block. Clear? In the similar way, this is our 4 kg block. For 4 kg block, if I draw this as a free body diagram, clear? Tell me.
Again, it will be against gravity.
M into G.
For G and T will be opposite to G.
Okay. Understood? Now, second thing, like,
Yes.
but don't say like, okay. Now, say here, if this pulley, if a mass of pulley is not given, for example, then say it is massless or smooth. Tension on both sides of the pulley is same. Clear? This pulley which I have shown now, this is a pulley. Nothing is given, always take it is massless. Massless or smooth. There is no friction. Massless or smooth. Clear? If this is the case, then tension on both sides of the pulley is same. If pulley is massless. If pulley is my system, get here, if pulley is my system, then how to draw the free body diagram for pulley? On pulley, who is going to apply force? Who is going to apply? These are the two string. Then on this pulley, what is the direction of tension force?
It will be downwards.
Very good, very good. And it will be T only. Similar here. And one string is above. Let us suppose this is T dash. Different string I am taking. T dash. Clear? Now since pulley is massless or smooth, then can you say this T dash? If I ask you like this entire system is in equilibrium. This pulley is not moving, like this pulley is attached with a fixed support. Will you see like this pulley is moving? Pulley will not move because it is attached with a fixed support. Clear? It is not doing any translation motion. So if you apply net force balance on pulley, if I ask you apply force balancing, apply force balancing on pulley. Clear? So net force, because all the forces are acting in the y direction, net force in y direction is equal to mass of system multiply its acceleration. Now net force in y direction in case of pulley, you can check. This is my system. And on the system, pulley is my system. If pulley is my system, then up positive, down t minus t, that is 2t, equal mass of pulley is negligible. So even mass of the pulley is negligible. Its acceleration is 0. Then this is 0. This pulley is fixed. Pulley is not moving. Okay. Then t dash will be equal to what? 2t. Clear? Pulley is like it is fixed. So acceleration of the pulley is 0. But don't say like for 1 kg and 4 kg block it is also at rest. No. 1 kg block, if I ask like, look at here. Clear? Here string is like that. Okay. This is 1 kg block. This is 4 kg block. Since pulley is at fixed, pulley is fixed, then this 4 kg block will move down with the acceleration. Then 1 kg block is going up with the acceleration. Clear? Any doubt till now?
Not also.
Why both are A? Clear? Since pulley is at fixed, pulley is fixed. If pulley is movable, then both are not A. We can't say like if 4 kg is moving with A acceleration, A 1 kg is going with A acceleration. We can't. We are not sure. Clear? Now look at here. Look at here. If I ask like Now tension is up, and here like 1 into G, here 4 into G, you can easily find tension balance, that is force balancing equation we will do later, okay? My concept is that. Now can you draw the free body diagram of in this case? If I ask you, for example, this is the case. Pulley is like this. And two blocks are there. One block is like this. String. Then one block. Can you draw the free body diagram of M2, M1 and this pulley? Please draw. Clear? Please draw. Okay. And if nothing is given, like in which direction, always assume. Consider in your mind like M2 is heavier and M1 is lighter. If your assumption is correct, then acceleration will be positive. Otherwise, it comes out to be negative. See, this is my system initially, okay? I just consider this is my system. Then gravity is applying a force like this, M1 into G. One is normal reaction force due to this surface, and one tension like this. Okay. So on M1, if I draw correctly like this is my M1. One is gravity, tension, one is normal. Clear? Similarly for M2, okay, if you draw the free body diagram for M2, in which direction tension will be on M2?
Upwards.
Very good. Very good. So its free body diagram will be gravity is like this. There is no normal. Okay, it is not in contact. M2G. In free body diagram, we always include all the forces with their direction and the magnitude. Clear? But if I ask this pulley is my system, if this pulley is my system, okay, then for this pulley, in which direction of tension will be there?
So which direction?
Very good. On this. Very good. I hope you understand. Okay. After this, write down. Have you written this? Written? Okay. After this, write down spring force. Did you write like?
Yes, sir, I wrote it down.
Okay. After this, write down a spring force. The spring force. There, spring force is just like a tension in a string. Okay. Tension in a string, just like a tension in a string. But little bit why we are saying it is a spring force, I will tell. It is similar to tension in a string. Okay. For example, this is string. Okay. If you ask me, this is string. But if I make this string coiled like this, it becomes what? String. Clear? Natural length. Let us suppose the natural length of the spring is L naught. L naught is the natural length. natural length. Clear? Now, once we apply a force, the string will extend like this. There is some extension in the spring. Once we apply a force like this. Once we apply a force, then the length of the spring becomes L. Okay. Then if I ask how much change, how much extension occur in the spring, how much extension? So extension in the spring will be L minus L naught. Final length after force is applied, final length of the string after force is applied minus initial length, that is natural length. So what is X? X is extension in the spring, extension. Okay, here in our case, why it is extension? It may be compression, because we are going to elongate. We are applying the force like this away from the center of the spring. Now what is center? I will tell. See, for this spring center will be layer, center of the spring will be in the middle for the spring. Okay, and you are applying a force away from the center like this. Okay, center, understand, center is center of mass. Every body has some center. Then center of the spring is at the middle or wherever it is. Okay, you are applying a force like away from the center like this. Away from the center means what? Extension. Clear? Simple. Away from center means extension. Applying force away from the center. Away from center, extension. Okay, force applied away from the center. It will do extension only. Clear? Up to this, any doubt?
No doubt.
So for a small displacement, you are not extending much. But I'm saying what? This x is directly, x is what? Extension. X is directly proportional to the f. More the force you are applying, more the force you are applying, more is the extension. Clear? F is directly proportional to x. It's very, very important. But remember, x should not be very, very high. It is not equal when you are extending much. Clear? Now f is proportional to x. If you remove the proportionality sign, this f will be equal to what? Kx. Somewhere like it is written minus kx. Why it is minus kx? But in our case, this f is what? F is what? This f is the force applied. Clear? It is equal to what? K into x. Clear? So remember one thing, like when you are applying a force, this force is directly proportional to displacement, and it is equal to spring force only when this x should not be very, very high. Clear? Under certain constraint means under certain condition, this you can say f is proportional to x. F is equal to kx. X should not be very, very high. Otherwise, we can't say like that. Okay. So spring force, this is known as F is equal to minus kx. This F is directly proportional to x, and this F is what? Actually, this F is equal to what? It is actually the spring force minus kx. Clear? So spring force is equal to minus k into x. External force is always opposite to the spring force. For example, write down direction. First of all, write down direction of spring force direction of spring force is opposite to extension spring. Clear? What is my observation? Let's look at here. See, look at here. This is a fixed support. Initially, the spring is in natural state. Okay. This is the natural state of the spring. Once you apply a force, after applying a force, okay, you can apply this much force only, external force, okay. Then my question is, what is the direction of spring force? From L naught, how much you have displaced? It is x. X is displacement from the natural length. This is L naught. And this total length, how much after extension? That is L. Then how much x? This x will be L minus L naught. Now this will comes out to be positive. Either you can say extension in the spring, or you can say axial displacement. Axial displacement, okay, simply. Displacement from displacement, simply displacement, okay. Understood? Now, can you axis displacement? In our case, it is like at L naught, when the length of the string, this is natural length. When the string has natural length, when the spring has natural length, then did you see any force acting on that? It is at rest. Rest means it is an equilibrium. No, did you see any spring force inside that? No. When the spring is in its natural length, there is no spring force. But here, since x is positive, then spring force will be formula FSB is equal to minus K into x. Then if x is positive, then sign of FSB will be what? Negative. Negative means in which direction spring force will be? Like this. Okay? Clear?
Yes, sir.
So this spring, once you release this F, once you are removing the applied force, that is F, then because of this FSB, it is coming back to its natural length. Understood? Once you remove this applied force, that is external F means F is the force applied or deforming force. The force which will deform the shape of the spring. If you apply that, if you remove that, then because of this FSP, it will come back to its initial state. It will take some time. It will not come instantly. Okay, understood? And here, if I am saying like you have taken x or x from here, okay, x from here, then you can say like this is x or y. Okay, origin. Here, understood?
Yes, sir. Understood.
Oh, now again I will ask you only. Just tell me the direction of spring force. This is spring, natural state. Okay, no force acting on that. Now, once we apply a force on that, like this, okay. Now the length is like this. It happened why? When you are applying a force like this, F. Okay,
Spring forces in that direction. Sorry, yeah, right direction.
very good, very good. So X a displacement from where I displacement from where I have displaced from here now. Okay, clear.
Yes.
Actually, we are saying this is the mean position. Natural state now. This position we are saying mean position because here net force is zero. Clear. There is no tension in the spring. Simple, it is loose. You can say. So here you are absolutely right. Like x, the x will be for the L minus L naught. Since L is less than L naught, so you can check like x is negative. Now, what is the formula of FSP? FSP comes out to be minus k into x. Since x is negative, already one negative is there, then FSP will be positive. Positive means in which direction? This is the direction of spring force. So in compression, always you can check. Direction of spring force is opposite to that of extension in a string. You can check x is like this. This is the direction of x. Spring force will be like this. Okay. In the previous case, you can check extension, direction of extension is like this. And direction of spring force is like this. FSP. In the right, you can check here is spring force in the right, but direction of extension x will be like this. Both are opposite. Clear? Understood?
Yes, sir. Yes.
Now moving to the, but remember one thing, like if you remove, this is a concept, very, very important concept. If you remove that applied force, if I remove this F, if I keep it zero, then this spring will take some time to come back to its natural state. Okay. It will take, if you ask me, like it will take less time to come back to its natural state. Less time not, it will take some time to come back to its original state. Because it is in compression form now. It takes time to come back to its natural state. Now moving to the next factor affecting the, write down the heading, factors affecting spring constant. Spring constant. So what is the spring force? Spring force is F is equal to minus kx. What is k? K is spring constant. Say x is the extension in the spring. So first point, it depends on type of material. This k, I'm talking about this k, that is spring constant. Okay, what are the, because k will also play a key role in spring force. F is a spring force. You can write FSP also if you wish. The spring force depends on two things. One is extension. Second one is K. K is a spring constant. This is spring constant. What are the factors that will decide the value of this spring constant? Like whether it is high or more, or what is the value of that? So first is write down, this K depends on the type of material. Every material has different types of spring constant. So write down, it depends on it depends on type of material. So K is directly proportional to the strength of material. More the strength of material, more is the K. Clear? Understood? Next, write down K is inversely proportional to its natural length. If you decrease the natural length, K will increase. What is the meaning of that? Meaning is that, for example, you are having a one spring. Its natural length is L naught, and spring constant is K. Clear? Now, if you cut this spring, for example, if you cut this spring, if you cut into three parts, three equal parts, okay, this is L naught by 3, okay, like this. Understood?
Yes, sir.
So when you cut into like three part, then my question is now natural length. Here it is not like K1, here K2. I'm assuming here K3. It may be equal, it may be not equal. I'm not worrying regarding that. But I'm saying that if you cut the spring, into small part, if you take a long spring, if you take a small spring, then which spring easily cut? If you want to cut with your hand, if you want to destroy this, then which string takes less time, and which can be cut or which can be destroyed easily, which is having more
The
length? Because
long
long spring has less K, then you can easily break it. But the small string, it is not easy to break. So K is inversely to the natural length. So here K, in first case, K will be inversely to the natural length. If I remove this proportionality constant, then I will get what? K is equal to some constant, that is m by L naught, equation 1. Clear? In this case, K1 is inversely to the 1 upon natural length. Okay, L naught by 3. Then K1 will be, let us suppose constant, any constant will be m only. Proportionality sign, if you remove, you will get a constant. So in natural length is L naught by 3. Equation 2. If you divide equation 1 by equation 2, then what you will get? K by K1. M by, you will get what? Tell me. It is 1 by 3 now. So
yes,
K1
sir.
will be what? 3K. Similarly, K2, because same length is here, L naught by 3. Similarly, K3. Clear? Understood?
Yes, sir. Understood.
Okay. Next property. Third, write down. Write down third property. K is directly proportional to the R to the power 4. What is R? I'm telling. See, this is a spring, okay? I will draw here like this. And this spring has two radius. One is radius of a spring. These are a circular end. Can you say this is the circular end? This is having the radius, okay? This circular end has radius. That is R. Okay. But this wire, this straight wire, no, it is not coiled. It is also having certain radius. It is also small circular cross section area. Then it is also having certain radius. It is small r. I am drawing here, okay? Okay. So what is this small r? Small r is the radius of wire. Radius of wire from which this spring is coiled or made. What is capital R? Radius of spring. Okay. Spring. Again, I will draw like this. So this is wire. This wire has certain cross section area. I'm drawing here. It is just like that. This is R. Okay. And this is a spring. Spring has circular spring, not circular. It has also radius. Okay, radius of spring. Understood?
Yes,
So
sir.
K is directly proportional to the R to the power 4. Clear? So more is the K. R is what? R is the radius of the wire, small r. So if the radius of a small wire is very, very high, then value of K is heavy. If you take a thick wire, then it has more K. Thick wire has more R. Clear? If you take a light wire, means very, very thin wire, then you can break it easily. But if you take a thick wire, you can't break it easily. Okay. Next, write down last factor. K is inversely proportional to the cube of the radius of a spring, R cube. Clear? K is, so if I combine like what I've explained, if you combine all the factors, first is K is directly proportional to the what? Inversely to L naught. We got K is directly proportional to the R to the power 4. K is inversely to 1 upon R cube. And one is K is, if you combine all these factors, okay, if you combine all these factors, then you will get what? K is inversely to the what? R to the power 4, L naught.
By L R cube.
Okay. Once you remove this proportionality constant, you will get a constant. One constant is C. C R to the power 4, L naught R cube. Okay. Understood?
Yes, ma'am.
So I will stop the lecture because 5 minutes is left. I don't want to start any new topic. Up to this, you have any doubt?
No doubt, sir.
So in the next lecture, I will discuss some numericals or nuclear force and those things I will not discuss. I will discuss free body diagram with you. Then I will discuss how to tackle the pulley string block problem. Okay. We will solve enormous problem. How to apply force balancing equation. Those questions, pulley, one pulley is there, two pulley there, many pulley are there. How to apply those questions, how to solve. Clear? Pulley is a moving pulley, fixed pulley. Every question I will solve. Okay. We will solve it together. Okay. Thank you so much. Take care.
Yes.
Bye bye. Bye.
Thank you.